Hey guys, welcome back to Civil Learning Online. And today in this video I am going to discuss about the Stokes theorem. In the previous video I have discussed about Green's theorem as well as the Gauss divergence theorem, and all these three theorems are very important from the exam point of view, and I hope you have watched those previous videos, previous theorems. If not, the link is in the description. And without any further delay, let's begin the solution of this numerical. So, coming to the solution of this numerical, the question says, verify Stokes theorem for the vector field f vector equals to 2x minus y I cap minus yz square j cap minus y square z k cap over the upper half surface of the sphere. This is the equation of sphere x square plus y square plus z square equals to 1, bounded by its projection on the xy plane. So before solving this numerical, one must know what the Stokes theorem says. So here we go. See guys, here if we have a closed this Stokes theorem is for the for the open surface bounded by a closed curve. So here we have this C indicates the closed curve. Integration of the f vector dot dr vector equals to surface integration of the curl of vector f and the dot product with its n cap. N cap represents the normal vector or the unit vector normal to that surface, and ds is for the surface. And if we draw the diagram of this problem, then it will take this form. See here, this is our axis, this is z axis, and this is our y axis, and this is x axis. And here it is we are provided with the equation of a sphere, means this is the lower portion of the sphere. As in the problem, we are provided that the bounded by its upper half surface of this is equation of a sphere bounded by its projection on the xy plane, and this is our xy plane. So here it is bounded on the xy plane, and now this is the diagram of this given problem. And now as per this diagram, we need to do some assumption that are not assumption but the steps for which are to be taken for solving numerical based upon the Stokes theorem, and after that we will proceed the solution with this numerical. So let us write here solution. So let us write few line here. Let us assume that this we have two things from the equation, that is C and S. So write here solution, and let S be the upper half of sphere x square plus y square plus z square equals to 1. See, this is equation of a sphere, and we are already said in the question that projection on xy plane means half of the sphere is below xy plane. This is xy plane, so half of the sphere is below xy plane and upper half is above xy plane. So we have assumed that the upper half of this upper half projection of that sphere is S, which is above the whose projection is on the xy plane. Similarly, also C be the circle of S. See, if a sphere is cut by xy plane, then we are also having a circle here. So this circle is represented by C. C be the circle of S whose radius is 1. If you remember the equation of a sphere, then it is x square plus y square plus z square equals to r square. Means r square means 1 square will be 1, so its radius is unity. And for this circle z is 0, so here it will be z equals to 0. Now we need to write the parametric form of x and y. So it is simple. Parametric form so here parametric form of x equals to a cos t, and we have radius a or r equals to 1, so 1 sin t, sorry 1 cos t, and y will again be equals to r sin t, so r is again 1 here, so sin t, y equals to sin t, and z equals to 0, and the value, this t is varying, t is angular form, sin t is angular form, so its value varies between 0 to 2 pi. Now let us proceed with the solution, and first of all we will find the value of this LHS, and we are asked to verify, means we have to bring LHS equals to RHS. So first of all let's just find LHS value, and then we will find RHS value, and then if both come equals, then our Stokes theorem is verified, which we are asked to do in this numerical. So this was the LHS portion. Similarly, I have put the values here. We have f vector equals to this much, and dr vector equals to I cap. This is valid for all each and every numerical. Whenever you are multiplying any vector with dr vector, then it will be same. Now what we need to do is we have to multiply this this I, j, k cap represents the unit vector normal to the x-axis, y-axis, z-axis respectively. Now multiply this I cap with I cap. Whenever multiplied with I cap, if I cap is multiplied with I cap, its value is 1. J cap is multiplied with J cap, its value is 1. K cap is multiplied with K cap, its value is 1. But if it is multiplied with I cap and J cap, then its value will be 0. So due to that reason, if you are multiplying, then this term is going to multiply each and every term. Algebraic multiplication, I hope you know the concept. This much portion will multiply each and every term. Similarly, this portion will also multiply each and every term, but here when I is multiplied with j, it becomes 0, so we will take only the term which are multiplied with I cap. So I cap is multiplied with I cap, then we will have here this is integration symbol, and 2x minus y, and I cap is multiplied with I cap, so dx, and again j cap will be multiplied with j cap, so minus y z square, and j cap is multiplied with j cap, so dy, and here we will have minus y square z times dz, and simply close the bracket. Now what we need to do is we have to find the derivative. So integration c, and 2x is multiplied with dx, so we will have 2, and y is y is derivative with dx, it will be 0, so minus, now we are here, this minus is here, and multiply derivative of y z square, y times z square with respect to y, dy, d is y, then y derivative of y with respect to y will be 1, and this z square is as it is. Now here we have to find the derivative of y square z with respect to z, so derivative of z with respect to z will be 1, and we have y square as it is. Sorry for my mistake. See here guys, we have that z is equal to 0, so we do not need to bring this z lower, because its limit is 0, its value is 0, so these two gets 0, so we will have only remaining here phi c 2x minus y times dx. Now we need to take only this much portion, these two portion are omitted because z is 0. If we had some value of 0, then we need to integrate, as I have done here, we need to proceed in similar manner, but here it is 0, so we do not need to bring these two terms below. Now what we have the limit in terms of x, and it is varying from 0 to 2 pi. Our value of t is varying from 0 to 2 pi, so 0 to 2 pi, and we have to write x in terms of t, and y is also in y in terms of t, so x will be equals to cos t, so 2 cos t minus y equals to sin t, so sin t. Now, and we need also to find the value of dx in terms of t, so before that what we need to do is divide dx by dt and multiply this by dt. And after now what we need to do is we have to find the value of dx by dt. As we know, we have written here that x equals to cos t. So if we differentiate it on both sides with respect to t, then what we will have, dx upon dt equals to derivative of cos t will be minus sin t. So we have got the value of dx by dt. So in next step, what we will put the value of dx by dt. So here we will have 0 to 2 pi 2 cos t minus sin t, and multiply this by dx by dt. So dx by dt is minus sin t multiplied by dt. Now multiply this and find the derivative, putting the upper limit and lower limit. Now we have multiplied here 2 with minus sin t, so minus 2 sin t cos t plus minus and minus will get plus, and sin square t dt. Now we have a formula, that is sin 2t equals to 2 sin t times cos t. So I have made it at written is at a 1 as a 1, that is sin 2t equals to 2 sin t into cos t. So we have this, and sin square t dt. Now on integrating, now we need to integrate, and before integrating we have to change this sin square t equals to 1 minus cos 2t by t, cos minus 2, 1 minus cos 2t by 2. It is also formula, so we have just simply changed this sin square t to 1 minus cos 2t by 2, and now we have integrated it. So on integrating sin 2t, we have a formula, sin integration of sin ax equals to integration of sin will be minus cos ax upon a. So here we have this formula. So here minus sin 2t will be minus cos 2t upon 2, and minus is multiplied with minus, so it gets plus cos 2t upon 2. This is the formula which is the integration. Now see here we have 1 here, and integrating 1 with respect to t, we will have integration of 1 with respect to t will be t. So t and this lower portion, this is a common base for both the terms, so 2 will get split. 2 will be for this 1 also, and this cos 2t will also be divided by 2. And again here we have cos 2t, and integration of cos 2t is sin 2t, and sin 2t upon integration of, similarly here we have integration of cos ax will be sin ax upon a. So this 2 is multiplied with this a, we have a again here, so 2 times 2 will be 4, and sin ax, that is sin 2t. And now we need to put the upper limit first and then lower limit. Upper limit first of all we put the upper limit, and then lower limit is subtracted from the value which we get after putting the upper limit. See how it is done in the next step. So guys, now let us put upper limit and lower limit in this term. Then we will have cos, and here we have 2, and in place of t we will put 2 pi, so it will get 4 pi upon 2. First of all we are putting the upper limit, so plus 2 pi upon 2 minus sin 2 is multiplied with 2 pi, so 4 pi divided by 4. Now time for lower limit, and lower limit is subtracted, so cos, and 2t, 2 is multiplied with 0, so cos 0 upon 2 plus this gets 0, 0 by 2 0, plus minus, and sin 0 by 4. Now we know that sin 180 degree equals to 0, and sin 0 degree equals to 0, and here cos 360 180 times 4 means 3 twice of 360, so it will be, its value is 1 upon 2 plus pi, and this gets 0, and we will have another cos 0 means sin 90, so its value is 1 upon 2. So we will get here, on putting the value, we will get 1 upon 2 plus pi minus 1 upon 2. So we have got the value, that is pi. LHS equals to pi. Now we need to find the value of RHS. So guys, you can see here in RHS we have curl f. So let us first find the curl f, then we will simply put the value of curl f, then multiply with n cap, then integrate and find the answer. So for doing curl, we need to find the curl of f vector in this manner: I, j, k, curl by curl x, curl by curl y, curl by curl z, and the term coefficient of I is here, coefficient of y is here, coefficient of coefficient of I is here from the equation which we are provided in numerical. See here, I am going to show you here. We have this is here I, coefficient of I is, and here, and coefficient of j is minus yz square, so it is written here below the j. Similarly, coefficient of k is minus y squared z, so minus y squared z is below, written below the k. Now what we need to do is simply we need to find the curl of vector. First we will proceed with this I cap. So I cap, write it I cap here. Now cover this and this, whatever we show, we need to do the cross multiplication, and this here it will go down and it will go up, and down will be positive, upward will be negative. So now differentiate this portion, this y squared z with respect to y. On differentiating y squared z with respect to y, we will get minus we are differentiating minus y squared z with respect to y, so minus 2y z will be here, so minus 2y z. Now as I said, we are proceeding down means positive, so the symbol is negative, so it will be as it is. But here, now see here, sign will be changed. Now what we need to do is we have to proceed up, and on multiplying minus y squared z, we are differentiating this minus y squared z with curl by curl z. So derivative of this y minus y squared z with respect to z will be 2yz, because it will differentiate only z portion, so derivative of z square is 2z, so 2z and y square as it is. Now here we have minus and we are moving up, so minus will get multiplied with minus sign, because I said when we move down we need to put positive sign, when we move up we need to put negative sign. But when we put negative sign here, then negative and negative will get multiplied and it will get positive. So this is for I cap. Now for j cap, now for z, cover this and this. So we need to find the derivative of this portion with respect to x and derivative of this portion with respect to z. So it will get 0 because there is no any like terms here. Here we are differentiating with respect to x, so here x is missing, so it will be 0. Similarly, if we are differentiating this portion with respect to z, here z is missing, so it will be 0. So we can write here minus 0 minus 0, this downward positive, upward negative, so 0 minus 0 times j cap. Now for k cap, again we need to find the derivative of this portion with respect to x and this portion with respect to y. So here x is missing, so it will get 0, and here we will have minus 1, so put the positive sign here, and k cap, and here we will have minus 1, derivative of minus y is minus 1, so minus 1. Now so the final value of the curl f will be, see here, here it is minus 2yz and here 2yz, so it will get cancelled. So we will have curl f equals to k unit vector. Now we need to multiply curl f vector with unit vector n, and we will have here curl f value is unit k cap multiplied by n cap. So now guys, we have put the value of curl f times n cap, and here it is ds. So curl f times n cap, we have got n cap times k cap times ds, and here we have r represents the projection on the surface s, and n cap here it is as it is, and ds will be equals to dx times dy divided by n cap and k cap, its determinant. Now guys, what happens when we are taking the projection here, then n cap, k cap, and its determinant will get 1. So finally we will have here interval integration of dx, here it is 1, nothing means 1 because it to gets u1, and dx dy. Now we have to put the limit of x and y here so that we can integrate it and get the final answer. So for that, first of all, what we need to do is we have to first differentiate this integrate this one in terms of y, and then we will integrate in x. So let me rearrange this. First of all, we will integrate it in terms of y and then in terms of x, and here it is 1. Why so? Because we have got that equation of circle in the xy plane is x square plus y square equals to 1. Equation of circle here, equation of circle in xy plane, x square plus y square will be, r square means r is 1, so x square plus y square will be equals to 1. And now from here we can write that y will be equals to root under 1 minus x square, because we can bring this x square on the other side, so y will be equals to root under 1 minus x square, and y plop and y as it is under root, so it will have two value, positive and negative, so lower limit will be minus root under 1 minus x square, and the upper value will be positive 1 minus x square. This is the limit integration in terms of y and integration in terms of x. So if we put y equals to 0 here, then we will have x at two values of x as plus 1 and minus 1. So here we will have minus 1 and 1. Now here we have the same limits twice, and here it is 1, so integrate with respect to integrate this 1 with respect to y, we will have y, and we can rewrite this as integration 0 to root under 2 times. We can write it in as 2 times. So here, see here how we can do this, minus 1 to 1 and 2 times integration of 0 to root under 1 minus y square and dy dx. So on integrating 1 with respect to y, we will have y, so put the upper limit, so we will have integration minus 1 to 1, and this y, integration of 1 with respect to y will be y, so I am putting the upper limit, so it will be root under 1 minus y square and 2 as it is, and the lower limit here, lower limit will be 0, so as it is, and dx. Now again we can rewrite this as twice integration 0 to 1, and this 2 as it is, integration of 1 minus y square. Sorry, we have here limit is x square, so here it will be x square and x square dx. Now we need to integrate this root under 1 minus x square with respect to x, and for that we have a formula, so we will take it in the form of formula, and we this is similar formula which I have discussed in the previous video also when I was solving about the Gauss Jordan method, sorry, Gauss divergence method. And here we will have 4 times integration of 0 to 1 and integrate 1 minus x square dx. So integration of 1 minus x square is equals to, so this is the formula, and in place of a we have 1 here, so we can simply put 1 in every place of a. So on doing so, we will have, I am going to use this portion here, we will have here this 4 multiplied by x times root under 1 minus x square upon 2 plus 1 by 2 sine inverse x. So now, and limit is going to be 0 to 1. On putting the limit at in place of x, we will put 1, and in place of x our lower limit will be 0. So for doing said that, we will get 1 upon 2 multiplied by pi by 2. So this 2 and 2 will cancel out 4, then we will get pi here, which is our and we have got this value equal to our RHS, hence proved. And guys, I hope you enjoyed today's lecture. See you in the next video. Till then, stay safe and take care of yourself.